Last time we were together, we worked on factoring quadratic trinomials where the leading coefficient was equal to 1. It doesn't always work out that way. Many times we're asked to factor quadratics where the leading coefficient is something other than 1, and we're going to need some different tactics in order to be able to tackle that. To see where those tactics come from, let's go ahead, just like we did last time, and walk through the process of multiplying two binomials together. So 3x times 2x gives us 6x squared. 3x times negative 5, negative 15x. Negative 4 times 2x, that's negative 8x. And then negative 4 times negative 5, positive 20. So when we multiply two binomials, we get 4 partial products, and we're going to have two like terms. We're going to combine those. Negative 15x minus 8x, negative 23x. I've still got my 6x squared term out the front, and plus 20 behind. 6x squared minus 23x plus 20 is how that binomial multiplication would be simplified. Now, let's say we were asked to factor 6x squared minus 23x plus 20. Several different ways in years gone by that you might have learned how to factor this, and I've tried a bunch of them in class. I finally settled on this one for a couple of reasons. I think it mimics how the binomial multiplication takes place. It really cements where this middle two terms comes from. And it follows the pattern that we've learned earlier, where we look for factors of one number that sum to another. So we're going to use a method called factoring by grouping. We're going to go ahead and take that leading coefficient, the 6, multiply times the 20. So 6 times 20 gives 120. Now I'm going to look for two factors of 120 that add up to 23. So I've got 1 and 120, 2 and 60, 3 and 40. We could do 4 and 30, 5 times 24, 6 times 20, 10 times 12. Go ahead and make sure we have 8 and 15 in there as well. So now I need two factors of 120 that add up to 23, and I can see that that's 8 and 15. So I'm going to rewrite this expression with negative 8x minus 15x, replacing the negative 23x. So now I've got 4 terms. I've rewritten this quadratic trinomial with 2 terms in the middle. I've rewritten negative 23x as negative 8x minus 15x. The reason why we're going to do that is we're going to use a method called factoring by grouping. I'm going to chunk this thing into 2 groups of 2, and then go ahead and factor out a greatest common factor. 6x squared minus 8x. Okay, so 6x squared, that's 2 times 3 times x times x. 8x is 2 times 2 times 2 times x. I can see that I've got a 2 that matches up, and I've got an x that matches up. So a GCF of 2x. So 2x times what? If I factor 2x out of the 6x squared, I can see that I've got a 3x remaining. 2x out of 8x leaves me with 4. So 2x times 3x minus 4, the quantity. You can see this was the distributive property in reverse. 2x times 3x is 6x squared. 2x times negative 4, negative 8x. I'm going to do the same thing on the right-hand side with these 2 terms. I'm going to factor out a negative 5. I'm left with 3x minus 4. Now, what do I do with this jumble? Remember, I'm trying to factor this trinomial. If we do this right, the factors in parentheses are going to repeat. 3x minus 4. That's one of my factors. The 2 GCFs are my other factor. 2x minus 5. So this trinomial factors as 2x minus 5 is 3x minus 4. Let's practice a couple. 3x squared minus 10x plus 8. Similar type of problem, even down to where the plus and minus are located. I'm going to take my leading coefficient, the 3, multiply times the 8. Gives me 24. I need factors of 24. I'm looking for 2 that add up to negative 10. 1 and 24, 2 and 12, 3 and 8, 4 and 6. I know they have the same sign because this is positive 8, which rules out 2 and 12. I can see I'm going to need 4 and 6. Let's go negative 6x minus 4x, 3x squared, and plus 8. All right, factoring by grouping. Let's take a look. My first pair of terms, I can factor out a 3 and an x, and that leaves me with x minus 2. The back end, negative 4x and positive 8. Remember, if I do this right, I'm going to be left with an x minus 2 in the parentheses. How do I get to there? Well, I can see that 4 goes into 4 and into 8. I need that to be a negative 4. So I end up with x minus 2. So 3x minus 4, x minus 2 are my factors. One of the things about this particular method is these numbers can get big in a hurry. And whenever I factor anything, I want to make sure that I've factored out a greatest common factor first, if that's possible, before I do anything else. So I look at 8x squared plus 28x minus 120, and I can see that with 8, 28, and 120, I can go ahead and factor out a GCF. 4 goes into 8, 4 goes into 28, 4 goes into 120. Well, 2x squared plus 7x minus 30. Now I can factor my 2x squared plus 7x minus 30. I'm going to remember that I've factored out a 4, and that's part of my overall factorization as well. So two factors of 60 that are opposite signs, that when I subtract I get 7. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So when I subtract 12 minus 5, I end up with 7. 2x squared plus 12x minus 5x minus 30. Factoring by grouping now. 2x, x plus 6. Here I can factor out a negative 5, and I'm left with x plus 6. Still that factor of 4 from the beginning. 4 times 2x minus 5 times x plus 6. We've mentioned a little bit earlier when we talk about the graph of a quadratic, and oftentimes we're looking for where that graph crosses the x-axis, the x-intercepts. We're also going to hear those referred to as the zeros of a function. Can we locate those zeros without graphing? How do I know where this graph crosses the x-axis? It turns out that if we replace y with 0 and factor as we have done in the past, that we can find those x-intercepts, which we're going to refer to as zeros of a function. As an example, y equals 4x squared minus 17x minus 15. Let's rewrite that. 0 equals 4x squared minus 17x minus 15. Now I can use the zero product property. Factor this side. Well, 4 times 15, that's 60. We just did factors of 60 a minute ago. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 10, 5 and 12, 6 and 10. So two factors of 60 that subtract to make 17, that's 3 and 20. So 4x squared, the 17x I'm going to replace with minus 20x plus 3x, and now minus 15. Four goes into 4 once, goes into 25 times. So 4x times x minus 5, factoring out a GCF there. 3 goes into 3 once, it goes into 15 5 times. So I can factor out a 3, and it's going to be positive 3 because I want this to say as x minus 5. So 4x plus 3, x minus 5. that product equals 0. So 4x plus 3 equals 0, or x minus 5 equals 0. And we solve these two relatively simple equations. X equals negative 3/4, or x equals 5. Also in this section, we took a look at maximum or minimum value of a function, which we remember is the y-coordinate of the vertex. If the graph opens down, that's a maximum. The vertex is at the top of the graph. If the graph opens up, the vertex is at the bottom. That's a minimum. How do we know? We take a look at the a value. The a value is positive. It opens up. We have a minimum. If it's negative, it opens down. We have a maximum. This is vertex form. X minus p, x minus q. And I find the axis of symmetry by taking the average of the two, p plus q divided by 2. So x is going to equal negative 10 plus 8 over 2. So my axis of symmetry happens at negative 1. Great, the vertex lives on the axis of symmetry. I need to substitute in this negative 1 into my function. So negative 1 plus 10, negative 1 minus 8. That's positive 9. That's negative 9. So I get 3 times negative 81, which is negative 243, will be my minimum value.